Let's look at our agenda today. So we're going to have a look at what is the attribute structure. What are the possible issues with your existing structure? What is the ideal approach for attribute optimization? And how does UPV support you with that approach? So, talking about the attribute structure, attributes follow different structures coming from different authoring systems. This means the attribute names are different depending on the authoring system you're using. For example, a plant 3D will attribute constellation will look totally different than something coming from S3D or E3D PDMS and so on. The attribute structure includes attribute naming, the hierarchy, how are they organized, value formatting, etc. So, what are the possible issues with this? First of all, input from different authoring system follows different naming rules. Input from different sources can be lacking certain attributes, and therefore, input from different authoring systems cannot be brought into one hierarchy. So, talking about bringing something into one hierarchy, if you have, for example, in some application, some authoring system equipment name, in a different authoring system, it will be just name or it will be tag and so on. So we need to kind of get an identical base so we can put them together in one hierarchy. What I mean by hierarchy, I'll come back to that a little bit later. And last but not least, attributes might be completely missing, attributes you want to have in your model. So what would be our approach here? The approach would be, first of all, planning of an efficient structure and hierarchy. So how do I want my data to be organized? And according to that, analyze the existing attributes with respect to that structure. Cleaning up unnecessary attributes, because there's a lot of attributes in different software that just does not really help you in viewing, just cramping up your attributes panel and makes it harder for you to find the information you need instantly. Renaming attributes if necessary. Selecting change sets. So this means you can use UPV and custom attributes, for example, to select certain objects you want to change the data for, including the reporting function of UPV and adding attributes that are not existent. So what would those approaches look like? So when you have your authoring system on one side and UPV on the other, first of all, you convert the data with the UPV adapters so you can send them to the UPV builder. The UPV builder creates the session and the UPV model. The first solution we have is using custom attributes. So these are attributes that can change dynamically from within UPV and save this data set and load it as necessary. The other solution is to use plugins. This is SDK plugins for the UPV builder. So like renaming attributes or Excel import and similar, or even custom-made attributes that you have programmed yourself. Those put the data together with the UPV builder in the UPV model. And the third solution would be you have some information from third-party software like SAP or ERP systems, document management systems like Documentum, etc. And those can be actually integrated via the API, and the information flow in this case can actually go in both directions. Well, let's look at the live demo for this. First, we're going to open an older model, demo model we had, and look at the attributes here. So even though this model has been optimized already a little bit, when I, for example, search for this equipment here, D240, I will get some search results. And when I click on name, it will highlight this object, but the drum only. So what about the nozzles? When I click on the nozzle, look at the data structure we have here, I see, okay, except for this assembly path, we don't have any reference for this nozzle one in name to actually attach it to D240. In this case, this can even prove to be problematic when we open up an PNID for this. So see, it will highlight this N1, but that's not the drum we were looking at. And the other way around, it has marked nozzle 1, and when I click on the 3D objects found, it says 102 objects found. Why is this? Because the name is just N1, and we're mapping by name. So what can we do here? In this case, for example, we could use this assembly path that's given. So let me just pick one of them. Export it, which I'm going to do now. Just create a report, say new, and here we're going to say, okay, what do I want? I want name, and I want assembly path. So okay, and now it's creating report. Okay, not only the selected ones, select all, and here we go. Maybe I should have added task 2. So it's easier for us to navigate. Say task. I want task equipment only. So I'll set a filter. So now I have 631 objects found, and I'm saving these now as Excel file. And this Excel file lands basically here. Okay, needs a second to open up. Here we go. So we've got name, task, and assembly path. So what can I do with this data? I can just rearrange this a little bit for an Excel import, which I did in this file here, where we have the source attribute and the source value that we attach to. So source value will be the values we've got out of our report here, assembly path. The source attribute obviously will be assembly path. And here I just used an Excel formula to separate this assembly path with a backslash into a name and nozzle name. So you might have noticed the nozzle already has a name. It does not matter with the Excel import plugin. You can basically overwrite existing values and add new ones. So in this case, we're actually changing the values for name for the nozzles, and we're replacing them with the nozzle name. So after we imported this, the result will be a different one. Then it will look like this. So when I search for D240 now, it will still find it under name, but you see now it will highlight the nozzles along with the equipment. Why is that? Because we have changed, we click on the nozzle, changed the data structure and the hierarchy to name, and where did it go? Nozzle name here. So now I can actually use this hierarchy in a different manner. So we've got the custom attributes where you can add dynamic attributes that you can change at runtime. Those would be the ones highlighted in yellow. Those can be free text or code lists, as I got here. So I'll just change the value here. This also helps you when you double click on a custom attribute. You could even highlight and colorize according to the value. And by double clicking again, you're going back to the default view. Let me just revert all colors here. So the API again, on the other hand, gives you the option to integrate third-party software and to directly write the information to custom attributes or read from the attributes from the model, send requests to the software and visualize it. Another plugin we have is the rename attributes. For example, could we rename a attribute that's called name underbar one into name? If the attribute name exists, I recommend using the Excel input plugin rather than the rename attributes plugin, just because the functionality includes the option to have some names double. So with a hierarchy or utilization of the hierarchy, this could lead to confusions. But you can also create subfolders. As you see here, I've renamed attributes to UPV/AVH or status to UPV/status. So why would we do this? If we go back from model here, so to this one, you can actually see when I click on an item, I get a folder here, and now it contains all these attributes that were renamed. So by renaming attributes, you can also create structurized folders. But what about attributes that we actually don't need? How do we get rid of those? Well, that's also quite an easy task here. This can be done in Universal Plan View Builder. So this is why it is important then to actually analyze what attributes do I actually need. So when you go into settings, attributes, you can scroll down and say, okay, ambient, blue, green, red. That's usually color and display information used by some authoring systems, but has basically no deeper meaning for you and for when you're viewing the model. So you can easily mark these and remove them. Same thing goes for, in this case, diffuse. That's just the ones that I'm pretty sure that can go. Dry weight often is not, general dry information is most of the times not included in the attribute data. And this way, when you clean up your attribute scenery you have for your model, this can not only help you with sparing some confusion and saving on searching times within the attributes. Furthermore, the whole process loading times will be accelerated, and thus the performance of UPV will be improved. Additionally, you have an option when you go into your settings and click Configure Priority Attributes. Here you can also put some priority on the attribute display. So in this case, we have pipeline and name selected as priority attributes. So I can add, for example, nozzle name now, and click OK. So when I hover over a nozzle now, it will show me in the tooltip all priority attributes, the name and the nozzle name. And additionally, when you scroll down here, you've seen the first time I showed you this, I had to look where the nozzle name was placed. Here, I know that the name and the nozzle name are actually shown first. Now, you might ask, what is the custom attribute? What is the slide in between? This is because custom attributes are always shown directly below the attributes they're attached to. So in this case, condition is attached to name, and that's why it's displayed after name. Talk about hierarchy. So what did I actually mean with the hierarchy topic? You can change the hierarchy in UPV easily by going to settings and configuring your project tree. So we can go to system path, which is the default setting here. If you don't set anything, so once I click on an object now, you will see that it will take apart the object path and display it exactly that way. So that's maybe not the exact way you want to display your breakdown structure. And again, you have different structures for example, PDMS and S3D models. By importing additional attributes and clearing actually the attribute scenery and landscape you have in your project, you can do, for example, details like this, saying, okay, task, name, and for example, nozzle name. So again, when I click on a different object, click back here, now you see that the breadcrumb tree up here has changed. So here you see, okay, task is equipment, name is D240, nozzle name is null, because we haven't selected one. If I select the nozzle now, you'll see it will be selected here, and when I drop down, I can actually see all nozzles attached to D240. I can switch from equipment, for example, to piping, and I can highlight piping then and say, okay, please gray out the rest, make it transparent. So all these things you can do with UPV are enhanced and easier and more efficient if you have clear data structures. And UPV is one of the few viewers on the market that enable you to actually create and in a manner manipulate the structure and hierarchy to your needs. Also, when you're adding additional attributes, you can use a combination of the Excel import and renaming attributes and similar to actually load a bulk load of information that's not included in the original authoring system information. For example, here in this case, for the valve maximum shut-off pressure or service, short code, type, and similar, and information that we put in folders like body, bonnet body size, port size, or additional technical information like actuator orientation, actuator stroke speed, and similar. So UPV enables you to summarize the information from today, enables you to homogenize, make a homogeneous hierarchy and structure, no matter where your model or even parts of your model come from, to unify it and make clear, efficient structures.